Alright guys, it's Miss Summers with your notes today. On plate boundaries, these notes are a little different because I am going to be drawing them out as opposed to doing our normal PowerPoint, so just follow along with me. I have just my regular writing utensil, but I also have two different colors. I have red and blue. I don't care what colors you have, it's irrelevant as long as you have two different ones. Alright, so before we start talking about plate boundaries and looking at our essential question, what forms the different types of plate boundaries, we need to have a little background knowledge about what the Earth looks like on the inside as opposed to just the outside. So what I'm going to do is I'm going to draw a couple circles. I'm going to draw this little circle here and then another little circle around it. And I'm going to draw a really big circle. And then I'm going to put another circle around, but I'm going to kind of break it up. So it looks like this. So this is a cross section, essentially, of what the Earth would look like if we cut it in half. Alright, the Earth is layered. There's four main layers of the Earth. We have here the crust. That is where we live. It is the thinnest layer. It is also the coolest layer in that it is like cold and brittle. So it's cooler. Brittle just means it breaks easily. Brittle. Alright. This next layer let me see if I have an eraser. I don't like where I put that. This next layer, there we go, that's better. This very large layer here is the mantle. The mantle lies underneath the crust. It is the biggest of all the layers. It is a semi-solid layer. So it's plasticky. And what we mean by plastic is that it doesn't break the way crust does. So when it moves around, it has the ability to sort of mold and bend, whereas the crust doesn't. All right. The further in we go, we have the outer core. Now, what's fun about the outer core, the outer core is actually the only layer that's entirely liquid. All right, and we're going to talk about how we know these layers are liquid and solid later on in this unit. But it's liquid. It's an important layer because it generates the magnetic field around Earth, and that protects us from radiation from outer space. Because this melted metal is spinning around, the little electrons create a magnetic field, and that's how we are able to navigate using compasses and whatnot. And our final layer, this one right here, that is our inner core. All right, the inner core is the hottest layer. It is hotter than the surface of the sun, but it is solid iron. And you might be thinking, well, if it's so hot, okay, how is it still solid? It's solid due to the immense pressure of the Earth on top of it. Even though it's so hot, it should be melted. The Earth is squeezing all that material together. It keeps it in a solid form, okay? But I'm really more concerned about these two layers right now, the crust and the mantle. Those are the ones we're going to be focusing on for the next couple days. All right? So we have our anatomy of Earth, essentially. I'm going to scoot down here, and we're going to go back to the crust, that thin outer layer, that very, very thin part that we live on. All right? There are multiple kinds of crust, just like there is with pizza. There's multiple kinds of crust for the Earth. I'm going to change that to manual, because I see that it's autofocusing, and that's annoying. There we go, perfect. So there's multiple kinds of crust. Our first one, I'm just going to draw like a very thin little bar and put some water on top of it. And this is where the colors come in. I'm going to color this blue. And I'm coloring that blue because this is oceanic crust. Oceanic crust is the thinner of the two crusts. That's why the oceans are on top of it. But it is dense. And what we mean by dense is it has a lot of mass packed into a little space. So it's like heavier. Imagine it being heavier. The other kind of crust is called continental. Continental, I'm just going to draw a much thicker bar here, and I'm going to color this red. I've chosen red to be my continental crust. You can choose brown or green, I really don't mind. That's up to you. Continental crust, the main difference is this is far thicker. Alright, this is why continents rise up out of oceans. But even though it's thicker, it's less dense. So it's not as heavy. So imagine like a marshmallow or a pillow. It takes up a lot of space, but it doesn't weigh a whole lot. That's kind of what continental crust is like. Alright, now that we know our crust, we can now talk about what happens when pieces of crust come together. Alright, I'm actually going to come back up here to our Earth diagram. These things that I drew, the crusty crusties on the outside, alright, these are called tectonic plates. Tectonic plates. And these tectonic plates move around, alright? We talked about Wegener and how he knew that the continents moved around, but we couldn't figure out how he knew that, or like how it happened. We're going to talk about what happens when these plates move around, and then we'll talk about how we know how they move around. All right. So we have what are called plate boundaries. A plate boundary is where two tectonic plates meet, okay? And depending on how they're moving is going to change what landform occurs there. So we have three main categories that we're going to look at. Our first category are the divergent boundaries. Divergent boundaries. With divergent, I'm going to draw two arrows that are pointing away from one another. At a divergent boundary, two plates pull apart, away, something like that. They're going away from one another. And there are two types. Our first type is oceanic divergent. At the oceanic divergent, I'm going to draw my ocean. And I'm going to draw two little oceanic plates. And I'm not going to put them right next to one another. I'm going to give them a little space. And I'm going to draw some arrows. There's my divergence happening. I'm going to color them because that's good. Alright, now, what your brain wants to think is, okay, the ocean plates move away, therefore there's this big gaping hole in the ground. But that's actually the opposite of what happens. When these plates move away, magma, which is melted rock, has a chance to come up, and when it touches the water, it's actually going to cool and solidify. So I end up making new crust. So new crust is made. This is called a ridge. A ridge is like an underwater mountain. Oh, that's behind. A ridge is an underwater mountain. This is common in the Atlantic Ocean. You may be familiar with the Mid-Atlantic Ridge. It's just this ginormous underwater mountain range. All right, so I'm creating crust here. The other type of divergent boundary is the continental divergent range, or divergent boundary, excuse me. And what I'm going to draw some like sevens, but they're going to be kind of funky. I'm going to draw some backward sevens, and I'm going to add this, and then I'm going to draw my arrows. See, I've made force perspective. That's what that is. It's perspective. All right, so this is my continental crust, my thick, less dense, squishy crust. And what I have made here is just what it looks like. This is a valley. I have made a valley. This forms rift valleys. All right, rift valleys continually widen over time. All right, you may also form what are called linear seas. Linear just meaning line. The Red Sea is an example of a linear sea that separates Egypt from the Arabian Peninsula. That is slowly spreading out. All right, Saudi Arabia and Egypt used to be connected like hundreds of thousands and millions of years ago, and as that gap between them widens, water started to fill in. Another example of where you can find this would be the East African Rift Valley. So that's around like Ethiopia, Somalia, parts of Tanzania, I believe. I could be wrong. I need to check my geography. But it's that Horn of Africa on the eastern side is literally ripping itself apart from the mainland. And eventually they will no longer be connected. All right? Okay. Those are our two divergent boundaries. I'm going to flip my page just so I have enough space because I want to keep them all on the same page. Then we'll flip over and we're going to talk about our next type of boundary, the convergent boundaries. Convergent. Let's see if I have it. All right, for convergent, I want you to draw two arrows that are facing each other. So it's literally the exact opposite of divergent. So here's my convergent boundary. There's convergent, okay? So it's pretty easy to make a definition. Convergent happens when two plates collide, come together, any other menagerie ways of saying that, right? There are a lot of types of convergent boundaries. There's 3 of them, all right? So there's a lot you need to know here. The first one we'll look at is the continental convergent boundaries. So again, they're coming together. So I'm going to draw my very thick continental crust. I'm going to kind of have it come up like this. And then I'm going to have another one right here. And I'm just going to draw arrows upwards. I'm going to color it red so I know it's continental. I know it's kind of hard to tell from this picture, but what happens is kind of what you would expect. This forms mountains. This forms mountain ranges, very tall mountains. An example of these would be the Himalayan mountains in Asia, where Mount Everest is. It's where like 8 of the 10 tallest mountains in the world are. Another example, the Appalachian Mountains. So, God, I hope I spelled that right. If I didn't, I'm sorry. I need to turn my North Carolina card in if that's not right. But the Appalachian Mountains to our west were formed millions and millions of years ago when 2 continental plates started to collide with one another, and what happened is they get stuck and eventually they just break and they move upward. All right. Over time, the Appalachian Mountains have worn down, which is why they're not as tall as the Himalayas, just because of their age. All right. Our next one, that's continental convergent. Our next one we're going to look at is continental oceanic convergent. All right, so they're still coming together, but now because we have a different plate, it's going to behave differently. So I'm going to have my continental plate. I'm going to draw it going this way. And we'll leave a space there for it. And then I'm going to draw my ocean. And I'm going to draw my little oceanic plate. Remember, my oceanic plate is thinner, but it's less dense. It's heavier. Because it's less dense, as these plates collide, this oceanic plate gets forced downward. All right? We call this make sure you can see that, subduction. All right? That's when a plate is forced down into the mantle. All right? And because the oceanic, I'm going to write this over here to the side, the oceanic plate subducts because it's dense. It's always going to be the denser plate. Dense things want to sink. Oceanic plates subduct due to density. So I'm going to color my stuff, I'm going to color my stuff in real fast so you know which one is which. So there's a couple really interesting things that happen here. So the first thing that happens, all right, as this subduction happens, you see there's this little gap right here, this little space where there's a little seam that's formed, like between my fingers there. This is actually a trench. And you might be thinking, well, a trench is a hole in the ground. Kind of. It's a seam where two things meet. So trenches are really skinny. Even though they're really deep, they're really skinny. It's right here. There's your trench. Trenches happen at convergent boundaries, not divergent. Your brain wants to think the other way around. Please tell your brain to get it right. Okay? Now, so we have our trench. That's cool. As this plate descends, it's going to melt into magma. All right? That rock heats up. It melts. That's cool. As the magma comes up, it's going to form a volcano. It's going to form a volcano. So continental oceanic convergent boundaries form trenches and volcanic mountain ranges. So an example of this would be the Andes Mountains in South America, the Cascade Mountains in Washington State, so that's like Mount St. Helens in Washington that erupted back in the 80s, is a result of this. One plate is going under, producing the magma that fuels a volcano. All right, and our last one, our last convergent boundary, I'm running out of space here, but I'm going to make it, are the oceanic, that says oceanic, not oceanic. Oceanic convergent. So what I'm going to draw here, I'm going to draw my water. I'm going to draw my two plates. One is going to subduct under the other one. Again, it's whichever one is denser. And the same thing is essentially going to happen. The same thing that happened in the continental oceanic boundary is essentially going to happen. I'm going to draw my little arrows. All right. This plate is going to melt. The subducting plate melts. It forms a volcano, but this is not on a continent. All right. I still have a trench, just like I did with the other one. So I'm going to make trenches and volcanic island arcs. Now, some examples of this. You might be thinking, well, I know a volcanic island arc, Miss Summer, this is Hawaii. And I'd be like, that is a volcanic island arc, but it's not on a convergent boundary. That one's a little special. We're going to talk about it there. I'll be there in like 2 minutes, I promise. Okay. Thank you. All right. An example of this would be something like the Aleutian Islands up in Alaska, Indonesia, Japan. Those would all be examples of those oceanic convergent. All right. And our final boundary, I'm going to do this really quickly because I got to go cover a class. Our last one is our transform. All right. Transforms are fun to remember. How you remember, you put your hands together like this and you pretend you're a tiny little squirrel DJ and you go wiki, wiki, wiki. All right, draw two arrows that are doing this number. So for my picture, I'm going to draw a block. I'm going to make a little three-dimensional. One does this, one does that. Plates slide past each other. Now, what this causes earthquakes. Nothing is really made here or destroyed. It's just stuff happens. Now, a good note though, earthquakes happen at all boundaries. It's not just transform. It's just that's the only thing that happens at transform. That's why we talk about it. The example I do expect you to remember, also a really horrible sci-fi film, San Andreas. The San Andreas Fault is one of the most studied transform faults in the world. Based on where it is in California, it's heavily populated, and it's also one of the biggest ones that's on land that we can see. All right? So if you have questions, you should be able to tell me what happens at each of these boundaries. If you have questions, you just let me know.